Hello, welcome to the final section, Introduction to Recommendation Systems. In this section we're going to take a look at user-based and content-based strategies. Now we move on to the first video of this section, User-Based Systems. In this video we're going to look at user-based systems. Here we'll implement it with Scikit-learn. First, we'll assume that we have a set of users represented by feature vectors. Typical features are age, gender, interests, and so on. Moreover, we have a set of items. Assume that there is a relation which associates each user with a subset of items for which an explicit action or feedback has been performed. In a user-based system, the users are periodically clustered, and therefore considering a generic user, U, we can immediately determine the ball containing all of the users who are similar to our sample. At this point, we can create the set of suggested items using the relation previously introduced. In other words, the set contains all the unique products positively rated or bought by the neighborhood. Let us implement this user-based system with Scikit-learn. For our purposes, we need to create a dummy dataset of users and products. To do that, we first import numpy and add these two lines. Post that, we add these lines for creating a user dataset. Here we assume that we have 1,000 users with 4 features represented by integer numbers bounded by 0, 4, or 5. It doesn't matter what they mean. Their role is to characterize a user and allow for clustering of the set. For order products, we also need to create the association. We do it using these two lines. We assume that we have 20 different items. 0 means that a user didn't buy anything, and an association matrix where each user is linked to a number of products bounded between 0 and 5, that is, maximum. At this point, we need to cluster the users using the nearest neighbors implementation provided by Scikit-learn. So we import nearest neighbors, and then add this. We've selected to have 20 neighbors and a Euclidean radius equal to 2. This parameter is used when we want to query the model to know which items are contained in the ball whose center is a sample with a fixed radius. In our case, we're going to query the model to get all the neighbors of a test user with these 3 lines. Running this gives the value of neighbors. Now we need to build the recommendation list using the association matrix. This is the required code for the same. For each neighbor, we retrieve the products he or she brought and perform a union, avoiding the inclusion of items with 0 value and double elements. The result is a list of suggestions that can be obtained almost in real time for many different systems. This approach is also naive, because it doesn't consider the actual distance or similarity between users to weigh the suggestions. It's possible to consider the distance as a weighing factor, but it's simpler to adopt the collaborative filtering approach, which provides a more robust solution.